Alright, hello guys. How are you guys doing? So this is the last lecture of rigid body dynamics. So I hope you guys have been following the other lectures. Alright, so first of all, let me welcome you guys to the Unacademy JEE English. This is a brand new channel by Unacademy, which is India's largest platform for online learning for IIT JEE. And in this channel, everything is being taught to you completely in English. Alright, so I think most of you know and have been attending classes. And if you're new, let me tell you that this series that I host is aimed for 2020 aspirants. Alright, so guys who are looking to take their JEE examination in a few months. Alright, so the idea here is that I'm going over the key concepts quickly and then we are focusing on problem solving. Alright, so let's get started. So before we move forward with today's lecture, let me introduce myself one more time. Alright, so my name is Rohit Dixit. I study mechanical engineering from IIT Delhi. I've been teaching for IIT JEE for more than 7 years now, and I've taught for some of the biggest institutes that are there in the JEE field. I myself was JEE rank 447 and I've already coached many students to top ranks. Alright. Now moving forward, let's also talk a bit about the Unacademy subscription and the benefits that this has. Alright, so this subscription comes with benefits like live classes. You get to interact with your educators. You get live polls and leaderboards. You have test series and analysis, and you have live doubt clearing sessions. So all these plus points give a huge boost to your JEE prep. Alright. And on top of all this, you get access to India's best educators with a single subscription. Okay, so in case you're confused, who to study physics from, who to study maths from. So you can find all the good educators, one of the best educators in India with your Unacademy subscription on a single platform. That's the great advantage of having this subscription. Now, how do you get this subscription? This amazing subscription that benefits you so much. It's very simple. Install the Unacademy app. Once you've installed the app, go to the plus section. And in the plus section, select your goal as IIT JEE. Click on that get subscription button, and that's about it. Now you can also notice that the fees of the subscriptions have been kept very affordable. So if you notice that the 12-month subscription and the 24-month subscription are the most affordable. So I would advise, if you're planning to take a subscription, go for either of these because these will be most economical for you. You can see that the price between the 6-month subscription and the 12-month subscription is not much. For 6,000 extra, you're getting an entire year's subscription. So I would advise you to go for either this kind of subscription or this, so that you are not paying too much of money. So this is very affordable pricing, guys, compared to any of the fees that you might be paying elsewhere. And this will become more affordable if you use this code RD Live. So look at that code RD Live. You can use this to get your subscriptions. This will give you an additional 10% off and make this already very affordable subscription for quality education even more affordable. Alright. Now you can also join us on the Telegram app using the link that I'm showing here. Hi Moisha, how are you? Good to see you here. Alright. And if you join us here on the Telegram app, you will get all the notifications of all the lectures and sessions that have been conducted on this JEE English channel. Next, you can find me on Telegram. My user ID is this. I've shared a link for a group that I've created. I don't know if that link works or not. I'm still getting used to the Telegram app. I'm new to it, so pardon me if this link doesn't work. But of course, you can find me with my user ID. Alright, and any doubts and queries that you have, or any discussion that you want to have about physics, you can do that on Telegram. I'll try my best to reply to you guys as soon as possible. Alright, so without any delay, let's start today's topic. Alright. Hi Harsh, how are you? So today we'll be discussing about toppling and pure rolling. So yesterday we discussed cases of pure rolling. We realized that the tools that we have for analysis of pure rolling are, you can use Newton's laws, you can use energy methods, you can use momentum conservation methods, you can use angular momentum conservation methods, you can use impulse momentum theorems. Alright, so you have all these tools. Now, depending on what kind of question you have, you will pick one tool and attack the problem with that tool. Okay, so this was a problem that I had given you guys yesterday, so I don't know if you tried this. So let me know, Maisha, did you try this problem? So let me read this problem once. So this problem said that a hollow sphere and a uniform sphere of the same mass and the same radius roll down an incline from the same height edge without slipping. Now you can see the figure. Each is moving horizontally as it leaves the ramp. Okay, so where will these spheres hit the ground? The range of the hollow sphere is L. You have to find the range L dash of the uniform sphere. Alright, so were you able to find an answer, Moisha? Were you able to find an answer? So that is why you should attend all the lectures on a regular basis. See, if you did not attend the last lecture, you won't know what I'm talking about here. So since Moisha attends all the lectures on a regular basis, so I don't think there should be any problem for Moisha. Alright, probably. So what is the answer? What is the answer that you got? Let's see. I am waiting. This is simple rather. This looks slightly tough, but this is a very simple problem, let me tell you. I'm still waiting for an answer from you, Moisha. Alright, do you want me to solve this? If you're not confident about your answer, please respond. Okay. So no response. So why don't I just go ahead and solve this? So let's look at the cross section. Let's look at this diagram from this side. So the two spheres are rolling from here, and let's assume that this is some radius r. They come down a radius small r. Let's denote this with small r, because I think capital R was the radius of these spheres. Yeah. All right. I think I'll share. Okay, 2 minutes. Message are reaching late. Okay, no problem. All right. So what we can do is here apply energy conservation for rolling from here to here. You know that the friction that is acting will never do any work, nor will the normal reaction. The only guy of doing any work is mg. So since no non-conservative forces are doing any work, so I can apply energy conservation. So remember this, you always need to check whether there are any non-conservative forces doing any work. Alright, so Moisha says it's 1.09 L. Let's see if that is correct. So I'm doing it for any normal body. Okay. So I know the loss of potential energy should be equal to the gain in kinetic energy, right? So what is the loss of potential energy for both of them? So if both of them, let's say, get their centers down by height h, as I think had been mentioned. So let's assume this to be h, unless h is something else. Okay, nothing. So let's call this h1. Let's call this h2. All right. So delta P would be plus mgh1. All right. I wrote minus delta P here, and the delta P would be negative because the masses are coming down, so they will lose their energy. Okay. All right. Let's see. So this should be equal to the gain in kinetic energy. Now, kinetic energy in terms of pure rolling can be written as half I about ICR, which is the instantaneous center of rotation, times omega square. All right. So let's see. You can multiply both the sides with r square. What will that do? That will make this term as v, which is the speed of the center of mass with which the object leaves. Okay. So what I get my v or omega r whole square as is 2mgh1 r square over ICR. Okay. Now once I know this is my v square. So v becomes root of this. So v is square root of 2mgh1 r square over ICR. Alright. Now it is very simple. Hi Simajit, how are you? Good evening to you as well. Now this is very simple. When both these spheres are leaving this surface, both of them have their velocities in x only. Their y velocities are 0. So you will realize that the time they will reach, the time they will take to reach the ground would be the same. Okay. So let's assume it takes any sphere whether it is hollow, whether it is solid, whether there was a ring, the time taken to reach the ground would be the same. Why? Uy is 0. So you will realize that you can apply h2 equals half gt square. Alright, and because the radii are the same, so radii are the same, they will both, the center of masses of both of them will descend the same heights. Okay. If the radii were different, then yeah, I would have to apply different h2 values. So you will realize time would be the same for both. It would be 2h2 over g. Alright, since the time is same, I'm not even bothered about calculating the time. I know what is the range L. L would be t times the velocity of 1. L was the range for hollow sphere, I think. Yeah, hollow sphere is L. So let's start writing the values for the hollow sphere. So it would be T 2mg h1 r square. Okay, these are same for everybody. How about the ICR? For hollow sphere, I know I about ICR, which is this, would be 5 by 3 mr square. So 5 into 3 and mr square. So mr squares will get cancelled. I will get L as T times root of 6gh1 over 5. Alright. Now, what is the range of a solid sphere L dash? So L dash would be T times root of 2mgh1 r square. Again, these values are same for the solid sphere also. The only thing that changes is the ICR. So for a solid sphere, yes, Simarjit, I think Moesha is right. Oh, come on, please, don't let's not even go there, Simarjit. I'm just doing my part, okay? I'm supposed to be a teacher. I'm supposed to take care of my students, okay? All right. So what is the ICR for a solid sphere? That is 7 by 5 mr square. So let's see again. Mr squares will get cancelled. You will get your answer as T times root of 10gh1 over 7. Now all you need to do is divide these two. Alright, so let's see what I'm getting. L dash over L, that becomes, these T's will get cancelled. I will get GH1s will also get cancelled, 10 over 7 from here and over 6 and 5 over here. Alright, I hope you guys can see that. When I divide L dash by L, this is what I'll get. Okay, so this is very easy. So this will be 3, this will be 5. So you're getting this as root 25 over 21. Yes, Moisha had the right answer. So L dash would be 5L over root 21. Alright, that is my answer, which was solved correctly by Moisha. Well done. No, seriously, no need. No need. Alright, so that is it. Alright, so let's try this problem. This was another problem that I had given yesterday. Okay, I don't know how many of you tried this. So Moisha, did you try this? Simarjit, I'm always happy to help, and trust me, you just need to treat me as your teacher. That is it. That is my job. It is my job to take care of my students and guide them to the best of my abilities at least. Okay, so let's try this problem then. So in this problem you were told that a uniform cylinder of mass capital M and radius r is at rest on a block of mass small m. Okay, you started and then? Alright, so why don't I give you some time to try this problem on your own? So please guys, whenever I give you a problem, please do give it a try on your own, because it's your practice that is going to benefit you. Okay, I can solve all the problems. Of course, I have already cleared my JEE. I have been teaching for physics for so many years. So I can solve all the problems. But it is you who has to solve the problem at your exam hall. Alright, so whenever I tell you to try a problem, you should definitely give it an honest try. It's fine if you can't get it right. Don't be afraid of getting it wrong. That is what I am here for. If you get it wrong, I will guide you. I will help you identify your mistake. I will tell you what the right method is, but definitely try the problem. So let's see you guys try this one. So you've been told a uniform sphere of mass capital M and radius capital R is at rest on a block of mass M, which in turn rests on a horizontal frictionless table. Okay, you can see that in the figure. If a horizontal force F is applied to the block, it accelerates and the cylinder rolls without slipping. So pay attention. Hello Ankit, good to see you too. Alright, so yeah, cylinder rolls without slipping. That has been told to you. So pay attention to your language. Alright, now you have to find the acceleration of the block. You can also find the acceleration of the cm of the cylinder and also the alpha and anything that you feel like. Alright, there is usually a question that involves that they tell you this length and they ask you at what time will the two of them lose contact. So if I told you this x, then I may ask you at what time will the both of these block and cylinder lose their contact with each other. So you can try that also. Once you know the accelerations, that shouldn't be too hard to find. Okay. Alright, try it. I want others also to try this. Alright. And I really hope I don't have to solve this. I hope you guys can find the right answers on your own. Okay. What I can do, however, is I can show you some interesting ways to solve this problem. There is one usual method, and I can show you another interesting approach to solve this problem. Okay, we will talk about that in a bit. And I'm sure the way that I'll show you, you probably wouldn't have seen that anywhere ever. Okay, as I told you, that is how hard work pays. I had put in a lot of hard work when I was preparing for my JEE. I told you I finished my entire HCORMA, my Erudov, and I think all the sheets that my teacher used to give me within the first 6 months for the entire syllabus. And for the next 2 to 3 months, I was solving every problem one more time and with the aim that I'll solve every problem using a different method. So when you put in that kind of hard work, you get very clear about your concepts and then you can solve every problem by at least 2 3 methods. You have at least 3 4 methods to solve every problem. You can find the most efficient method and arrive at the answer in the smallest amount of time also. So I'll show you 2 methods. You can decide whichever you like. You can use. No, it's just hard work. It's nothing else. So if you work hard, you can also start solving any problem in so many ways. Okay. All right. So why don't you guys try this? Okay, this is a tough problem. This is not an easy one, by the way. So yeah, I can understand if you are not able to solve this also. At times, sir, there were less distractions. Yes, definitely, Ankit. All right, great, good to know. Definitely, at my time, there were so many. There were almost very little distractions. And we used to have different distractions though. All right, so there was no internet, there were no smartphones when I was preparing. I remember. All right, so yeah, these distractions were taken care of. But then these distractions also come with a lot of opportunities. I never had the opportunity of studying from great teachers or best teachers of India from the comfort of my home. I do not have access to the kind of material that you guys have access to when you are preparing. I only had 2 3 books and I had to rely on those books. That is why I had to start solving them again. Now, these days, there is so much content available for you guys over the net that you probably don't need to do that. But it's a lot of fun, by the way. All right. All right. I hope everybody is trying this problem, by the way. In case your focus is only mains, then you can skip this problem. This problem is meant for mainly for students who are preparing for advanced. But I think most of you guys should aim for advanced also, and since you won't have too much gap, mostly you won't have too much gap between your mains and exams, mains and advanced. So when you are going through this topic, let's try some problems of advanced level also, not only stick to the mains. Okay, so still waiting for your answers. Alright guys, you'll have to hurry up. I can't wait too long. That is why I gave you this question to try at home yesterday only. I was hoping you would have tried at home and I could just simply show you the solution here. Alright. Let's hope you guys are getting close to your answers, at least. Alright, just 1 second more. Okay. Okay, I was gonna make a joke about 1 second also, but let's forget it. I was gonna say, okay, 1 second from whose reference frame? I don't know if you know this, but time is also frame dependent. When you start moving at velocities which are closer to c, time slows down. So I'm sure Moesha is moving with a speed which is close to c, because 1 second of Moesha seems very long, at least compared to my 1 second. Alright, so try this. Alright. You got the angular acceleration. Okay. In my frame, I am at rest. Yes, everybody is at rest in their own reference frames. But I'm talking about your frame probably is actually moving with a speed close to c, because your 1 second seems very long. Anyhow, I'm not sure everybody would follow that joke. That is why I decided not to say it. Okay, 2m plus m over mr square. What is that? What is that? Your answer has to involve f, right? How can your answer be independent of f? How can it be independent of the force you're applying? What if the force was 0? Would you still have an acceleration? Okay, so you missed something somewhere, I guess. Also, it's dimensionally incorrect, if I may say so. There are no dimensions of time in your answer. Accelerations have to be meter per second square. Okay, this is taking too long. Why don't I just go ahead and solve this? Hopefully we can utilize the time better discussing some more theory. It's okay if you're taking long. This is a subjective problem. This is supposed to take a little bit of time, but not this much also. You guys probably are not used to solving too many good subjective problems. See, that is a problem when the JEE became objective. You guys focus only on objective problems. But trust me, solving subjective problems is more important to get a good understanding of your concepts. And that is why we still recommend you to solve HC or more subjective problems and subjective problems from elsewhere also. Even a lot of your JEE problems which are objective, they give you para form of questions, in which, let's say, I can ask you about the accelerations of the block, the cylinder, and the time it will take for them to get separated. So I can ask 3 questions from this one para and give you a subjective problem. Okay. So Moisha, let me know, do you want me to start solving this? Because I think I have waited much longer than 1 second and still waiting for an answer. So that is why you guys should listen to me. When I tell you try this problem at home, you should try it at home. I don't know what do you do after the lectures? All right, let's see. So let's see what is happening. What will happen? So this is small m. If I'm right, this is small m. Yep. And then you have a cylinder of capital M. Capital M and capital R. Okay. So imagine what will happen if I apply this force F. So this force F would try to give an acceleration to the plank. Okay. So the plank will have a tendency to move forward. As it has a tendency to move forward, the cylinder will apply at an infinite while loop. Okay. So the cylinder will apply a friction on my plank, which would be in the backward direction. Okay, that is the friction that the plank feels, and it is being applied by the cylinder. And as a reaction of that, my plank will apply a friction on the cylinder in a forward direction. Obviously, these two F's will be equal and opposite. So the first approach that I can say is, okay, so let me write the equations for each and every one of them. Let me imagine that my M moves with some acceleration of A. Let's write the acceleration. This guy has A2. This guy has an acceleration of A1. And let's assume that, okay, one thing very interesting that you will see. If you make the free body diagram of your cylinder, what do you see? Make a free body diagram of your cylinder. Let's see what you find. I'm sorry, I'm bad at drawing these shapes. So you have a force which is acting in the forward direction, right? The only force in the horizontal plane is F. Then there is one mg, and there is a normal reaction. So these are the 3 forces that are acting on this guy. Now, if I take torques about this one, what is the direction of the torque? The direction of the torque is this, which means any alpha would come in this direction. So this guy has A2 acceleration in the forward direction and also has an alpha which is also in this direction only. Alright, that is the only possible direction of alpha. The alpha, this is a case which is different from your usual cases, okay? Usually what you are used to is ACM in this direction and alpha also in this direction. But this is not the case in this. What happened to your writing today? Oh, my writing is just alright, but my drawing has always been bad. Alright, so please remember this. So your cylinder will have an ACM in this direction and an alpha also in this direction. Alright, now let's start writing the equations. So if I make the FBD of this guy, so if I make the free body diagram of my plank, so my plank feels 2 forces, one F, another small f, which is the friction due to the cylinder. So what is the equation that I can write for this? I can write that F minus small f equals small m times A1. Okay, that is the first equation that I'm getting. Alright, because my plank was moving forward with an acceleration of a1. Now let's start writing the equations for the cylinder. Okay, okay. See, forget about friction right now. What will this F do? This F will try to pull this mass forward. So if you look at this point on the plank, look at this point on the plank. This point of the plank. This will have a tendency of moving forward. So with respect to the cylinder above it, it is trying to slip forward. It will have a tendency of slipping forward. So the direction in which the cylinder will apply a friction on your plank would be to oppose this slipping. That is why this is the direction of friction that cylinder applies on the plank. Now, friction comes in action-reaction pairs too. So if your cylinder is applying friction on plank in this direction, the plank will apply friction on the cylinder in this direction. Why? Because see, look at the cylinder from the reference frame of the plank. From the reference frame of the plank, it seems that a point on the cylinder is trying to go backwards. This point is trying to go backwards from the reference frame of the plank. That is why on this, the plank applies a friction in the forward direction. I hope you got where that green friction is coming from. That green friction is the friction acting on the cylinder applied by the plank. Okay. Alright, so if I write equations for the cylinder now, the cylinder's FBT is right here. The only horizontal force is F. So I can write small f equals ma2. That is my second equation. Now third equation, I will take talks about the center. I will take talks about the center of my cylinder. So taking talks about C also. So let's see, taking talks about C. Let's see what that gets me. That will get me the only torque provided would be because of the friction. It will be counterclockwise. Okay. So how much will the torque be? The torque would be F times R, and this would be equal to ICM alpha. ICM why? Because I'm taking the torques about the CM. Okay. Please note that this time I'm not taking the torques about the bottommost point. Why? Why am I not taking the direction? Because of the torque. If the only torque this guy is getting is anti-clockwise, the alpha would also be anti-clockwise, right? How do you explain this? By the way, if I start taking thoughts about this, what happened here? If I took torques about O, do I see any torque? Why did I not take torques about O? Earlier I was always taking torques about O. This time I'm not taking talks about O. Why? And if you realize, if I took talks about O, I don't see any torque because all the three forces are passing through O. So how do I explain the alpha? How do I explain the alpha? The body getting that alpha. Think about it. It is not the instantaneous center of rotation. Absolutely right. It is not at rest with respect to the ground. Why? This is not slipping with respect to the plank. The plank itself was moving with an acceleration a1. That is why O will have an acceleration a1 in this direction as seen from ground. So it is not the instantaneous center of rotation because it is not at rest. Now if I took torques about O, I will apply a pseudo force here in the reference frame of O. I will apply a pseudo force. So let's use the same color only. So this pseudo force of MA1, this will give me the anti-clockwise torque that I'm looking for. You can realize this gives an anti-clockwise torque, and that is what will cause the anti-clockwise alpha. Alright, so if I wanted to take torques about O, I can still do that. I'll just have to apply this pseudo force and take the pseudo torque. Pseudo torque is the torque due to a pseudo force. Alright, so let's see. For now, what I'm getting my equation as, I'm getting it F cross F into R equals ICM, which was, this was a cylinder, so mr square by 2. times alpha. So let's simplify this a bit. So I am getting 2f equals m alpha r. Alright, so this is my third equation. Now let's take a look at all the equations. I have equation number 1, 2 and 3. Okay, so 3 equations. How many variables? I don't know what small f is. I don't know what a1 is. I don't know what a2 is. I don't know what alpha is. So 4 unknowns so far. So let's write the unknowns. What are the unknowns? Small f, a1, a2 and alpha. All 4 of them are unknowns. I have only 3 equations, so I need a 4th equation. How do I find the 4th equation? Yes, you can find the ICR also. But that's not going to help you much. Because the ICR is found in terms of V and omega. And V and omega will change, so your ICR will keep on changing. That is going to be a problem here. Right? So the ICR will keep on changing. So that is why it is always better for this analysis to be done in the reference frame of the CM. Because the ICR is not fixed. Okay. Yesterday I told you the distance of ICR D would be V over omega. Now V is changing, omega is changing. So you realize the ratio may change. Alright, so I need a 4th equation because I have 4 unknowns. The 4th equation will be obtained from the fact that there is no slipping. Here it says the cylinder rolls without slipping. So I will use this condition. If it rolls without slipping, that simply implies that the acceleration of this point on the cylinder is also a1. Okay, so what is the acceleration of this as seen from the CM? As seen from the CM, alpha is in this direction. So let's talk about point O now. Let's talk about point O as seen from the CM. So as seen from the CM, point O has an acceleration of alpha into r in this direction. And CM itself from ground frame has an acceleration of a2. Alright, so the ground frame acceleration of O would be this plus this. So it will be a2 plus alpha r. So acceleration of O, let's just write small o only. So I can see acceleration of O has to be equal to alpha r plus a2. Now this should be equal to a1, which I have already written. So that is my 4th equation. 4th equation I am getting from the condition of no slipping. No slipping condition gives me the equation that a1 should be equal to a2 plus alpha r. Now that I have my 4 equations, let's solve these 4 equations and let's try and get the answer. Okay. So, okay, how do I substitute things? I needed to find a1. So let's start substituting everything other than a1. So from here, let's substitute alpha r. So from here what I can say is alpha r equals to small f over m. So let's substitute this value over here. Alright. So when I substitute this, I am getting a1 equals a2 plus 2f over m. Now f I can substitute from here also. So here I'll substitute f, I'll get a1 equals a2 plus 2 over m times small m a2. Okay, from here I can say that a2 equals m a1 over m plus 2m. Alright. Now I can substitute this value of a2 in this equation and the equation value of f also. So substituting all these values, what I am getting is f minus small f being m a2. So this would be equal to m a1 plus a2. Oh, there should be a capital M here. Oh, wait. That's what I was thinking. Then how come I'm not getting any capital M's? Yep. Okay, F equals capital M here. So these M's will actually get cancelled, which is nice. Alright. So that makes the expression simpler. I am getting A2 as A2 equals A1 over 3. Great. So now I can from here write that MA1 plus F, and F is capital M A2, and substitute this value of A2 here. Okay, so finally I'm getting A1 as 3F over capital M plus 3M. Yeah, that seems dimensionally correct also. So this is my answer. Longish problem, longish solution, but finally I've got the answer. Okay. All right. So this part is done. I could have found the other parts also now. I know if this is this, I immediately know A2 from here. A2 would have been F over M plus 3M. Any simpler approach? I can tell you an alternate approach. Let's see if you find it simpler or not. Okay, that requires more thinking though. That requires even more thinking. Okay, this is the standard approach, taking torques, writing the F equals ma equations. So first let me know if you followed this. If you followed this, then I'll talk about an alternate method. So this is my method 1. So this is method 1 of solving. Tell me, let me know if you followed this. Alright, so you followed this, everybody followed this. Okay. Now let me tell you a bit about the second approach, the alternate approach that I solved this with. This is the standard approach that you will see in any of the books. Alright. The approach that I am going to show you now, you won't see in any of the books because nobody solves it the way I do. So let's see method number 2. Alright. So there is a small trick that we are going to use here. So this is A1, and initially, so let's talk about the cylinder. Initially the cylinder is at rest, okay, and let's pick a point here. Let's pick a point P on the ground, which is at this level. Okay, so now I hope you realize where I'm going with this. Before the motion had started, everything was at rest. Once the motion would have started, let's write then what happens then. Then this guy is at some point of time, let's say this is moving with V2 and this is rotating with some omega. Okay, after some time, I'm saying, let's assume that. I can assume the direction of omega normal also, it will come out to be negative automatically. So let's not bother about the directions. Here, let's assume any of the directions. So after some time, let's assume that this guy got here. The CM was moving like this with V2 and omega was like this. Okay, I don't need to find the direction of omega, it will automatically come out to be negative. Now, the interesting point is, during the entire motion, if you look at all the forces which are acting on this guy, they are mg, n, and a friction which is forward. And of course, because ACM y is 0, the acceleration in the y direction is 0, so n is always equal to mg, right? So if I look at this and if I see, are there any torques about point O? Are there any torques about point O acting on the cylinder? Is there any external torque acting on the cylinder with respect to point O or point P? So this method requires little bit of thinking, but then if you think that, then your calculations would get reduced. Okay. So let's see. No torque, exactly. Now let's exploit that fact. Now I can say since summation tau with respect to P external is 0, what does that tell me? That L about P should be constant. Alright. So what was the initial angular momentum about P? Okay, I'm not writing the directions because I know the directions would be plus Z and minus Z only. Okay, what is the initial angular momentum? When everything is at rest, it is 0. Okay. Why? U initial or V2 U2 is 0 and omega initial is also 0. The cylinder was at rest. Right. Let's see what is the final angular momentum. L final when seen from point P. When seen from point P, what is the CM doing? CM is moving in this direction. So let's judge the direction. Let's judge the direction of angular momentum. So if the CM is here and after some time the CM gets here, so I have to turn clockwise. Okay, so clockwise means minus K cap. Alright, thank you. So minus K cap. So angular momentum of the CM would be mv2 into r. This perpendicular distance obviously is r. Alright, mv2r minus K cap. So L final would be minus capital M v2 times r K cap. Alright, now let's talk about the angular momentum ICM omega. ICM omega also is in clockwise only, right? Because my omega is in clockwise. If the omega is in clockwise, so my ICM omega vector will also point in the minus K cap direction. So ICM I already know is mr square by 2. So ICM omega would also become minus mr square by 2 omega K cap. Now LP equals constant. Okay, let's write constant. We didn't know initially that it was 0. So constant, yes, it was 0 only. So from here I can get a relation between V2 and omega. Okay, let's see what we are getting. What we are getting is when I equate this and this. So we are getting V2 equals omega R2 by 2 with a minus sign. Omega R. Alright. I hope you followed this. Now, one very simple thing left. Differentiate this. When you differentiate this, what do you get? A2 equals, now the minus sign will take care of the directions. Okay, so A2 is minus alpha r by 2. Alright, so from here I get alpha r minus alpha r equals 2A2. Alright, I hope you're getting this. I just differentiated both the sides with respect to time and got alpha r in terms of A2. Now let us see what is the acceleration of O. Acceleration of O would have been A2 in this direction, alpha r in this direction. So I can write that acceleration of O equals A2 minus alpha r, which will be 3A2. And I also know that acceleration of O is equal to A1. Don't worry, don't worry. I have assumed the normal directions only, counterclockwise, counterclockwise. Now, once you know this, you can apply a simple equation. The simple equation that you know is F equals M of system times ACM of system, right? Which you can write as MA2 plus small m A1. The other way around. I have taken the expressions. Yeah, it's correct. It's correct. All right, now use this equation. that f should be equal to ma2 plus m1a1, and use this equation. If you use this equation here, you get f equals 3ma1 a1 by 3, sorry, a1 by 3 plus ma1, and from here I can say that a1 equals 3f over m plus 3m. I hope this is the same answer that we had gotten the last time also. Did we get the same answer the last time? Let me know if we got the same answer the last time. Or maybe I can just yeah, this was the same answer. Okay, so I've gotten the correct answer. Okay, so this is an alternate approach that I thought of solving this. See, the number of equations are lesser. I don't have to worry about f equals ma equations. I don't have to write the torque equations. This writing angular momentum conservation is simple. I find it simple. If you're not very comfortable with writing the angular momentums, then you don't do this. Once you write the conservation of angular momentum, then you differentiate it, you get this, then you write the equation for no slipping and write f equals macm, which is m1 a1 plus m2 a2. Okay, so then you get this answer. So I think I would have done it like this because this requires lesser number of calculations, lesser number of equations, but just a little bit more of thinking. You have to think a little extra. You have to think in the non-traditional way. And trust me, you will never see the solution of this problem done like this. Wherever you see the solution of this problem, you will only see it by method 1. Because I personally have never seen the solution with method number 2. Alright, so again, if you understand your concepts well, then this will be simpler. It is a matter of whether you understand your concepts better or not, well enough or not. If you don't understand what we are doing, then don't do this. You should be able to understand what you are doing. Okay, if you understand what you're doing, then you can always think a little extra and reduce your calculation bits. The equations are way simpler, the calculations are way simpler here. Yes, I know. Why? Because they don't want to think too much. Alright, see, I also thought about all this when I was a student. Most of these things I thought only when I was a student. Okay, so are you still okay? Are you okay with the directions, Moisha? Or do I need to talk about the directions again? What happened, Vineet? Did you follow this method? I think Vineet is feeling a little uncomfortable. No problem, Vineet. Yeah, I know, Moisha. It happened to me. You won't believe that this happened to me in IIT. In IIT, I had solved a problem which was asked in a mechanics course. So we were doing a course of mechanics in my first year, and I solved a problem using a non-traditional approach, and I was given 0 marks for it. All right. So for the sake of simplicity, I just assume the direction of omega like this only, like the traditional direction. Okay, so I'm assuming V2 is in this direction and omega is in clockwise, which you normally do. Because I don't want to think also whether omega will be counterclockwise or clockwise. So I'm just taking the normal directions. Yes, unfortunately this happens in IIT too. I had to go to the teacher after the class, ask the teacher why I was giving 0 marks. So the response that I got there will be shocking for you. The teacher told me I did not understand what method you used. I had to explain my method. And I had done a calculation mistake in the last part, so I was not getting the right answer. So that is why I got 0 marks. But once I explained the problem, once I explained my solution, only the last step was wrong. There was a calculation mistake. Suppose Here when I have to substitute the values, while substituting the values I had made a mistake. So finally I got 8 marks out of 10. It was a 10 mark paper question, and I finally ended up with 8 out of 10 in that question. But I had to explain my solution. And I was told to stick to the solutions that are being told in the class and do not venture out of that bracket. I was advised that in future you stick to the methods that I am teaching in the class. Do not use your own methods, because I don't have the time to understand everybody's method, and and I can't be correcting everybody's method if everybody is using a different method. It is too much of work for me. So yeah, that is how it is even in IIT. So it is a little sad. So all I'm saying is that I considered the directions in a traditional manner. Okay. So traditionally, how do you see the directions? You generally mark the direction of V2 as this and omega as this, right? So the alpha would also be in this direction. That is why the omega is getting in this direction. Moisha, you can ask the question to a lot of people, trust me. It is unfortunately true that is true for a lot of people. Not only for teachers, trust me, a lot of people in a lot of fields. That they're just there. Anyhow, I won't get into all that. I was talking about the directions here. So I know angular momentum of cylinder about P. How to write that? Angular momentum of cylinder about P can be written as angular momentum of Cm about P plus all these are vector equations, so plus angular momentum of cylinder with respect to Cm, and I already know this guy takes up a value of ICM omega, and this is R cross V2 times M. Alright. So I told you a quicker method of judging the directions. How to judge the direction? If you look at the Cm from P, the Cm, how is it moving? It is initially here, after some time it will be here. Alright. So focus only on the Cm. If you focus only on the Cm from point P, so imagine C was here initially and then C reached here in some time. So when you're looking at the Cm, initially you have to look in this direction, then you have to look in this direction. So you have to turn your head clockwise if you want to keep following the Cm. So the rotation of Cm about P is clockwise. Clockwise is always minus k cap, counterclockwise is always plus k cap. Okay, clockwise rotation means minus k cap direction of angular momentum, and anti-clockwise rotation would mean plus k cap. So you should remember that. So since I saw a clockwise rotation, I am writing the angular momentum as minus mv2r. I know the magnitude is mv into r perpendicular. R perpendicular is this perpendicular distance. So this is my r perpendicular. I know angular momentum, the magnitude is, so the mod of this is mvr perpendicular, right? So the mod I am writing as capital M v2 times r perpendicular, which is r, and I already know the direction. I judged it from the sense of rotation. Alright, the rotation is clockwise, so the direction is minus k cap. That is why I have written a minus and I have written a k cap. Okay, so that is the angular momentum of the Cm. Now let's talk about the angular momentum of the body with reference frame to the Cm. This I know will point in the direction of omega vector. And how to see the direction of omega vector? Omega vector, again, omega here is in clockwise. If the omega is in clockwise direction, so omega vector will point in the minus k cap again. So all I need to write is ICM times omega. So I am writing ICM, which is mr square, times omega. This is the mod, and direction, because the omega is in clockwise, so direction of angular momentum would be minus k cap. Okay, good. And that is why I am getting this minus sign here. And I am still taking alpha in this direction only, but substituting it with a minus sign. Minus sign just means that the direction of alpha would get reversed. I have taken the direction of alpha also like this, that is why I am writing this. But you realize here it is coming minus. So alpha is actually coming out to be negative. Negative means the actual rotation is clockwise. That is what is the meaning of getting my alpha as negative. And I knew in the previous problem only that this has to be, the alpha and omega would be in this direction. Alpha and omega. So that is why I am getting a minus sign here also. This minus sign in my alpha r is telling me that only. That alpha r is in minus, has a negative value. So it is in the opposite direction. That is why in the answer it got added. That is why it became, instead of, it is getting added to 3a2. Okay. Alright, so if you followed this, then should we move forward? So this is a very unconventional method of solving this problem, by the way. A lot of you may even feel confused about, okay, why, what are we doing? But I just wanted to show you that you can use something like this also. See, we never wrote any F equals ma equation, we never wrote any tau equations, torque equations, and I still got the right answer. All I did was summation F external equals MACM. Yes, this I used. And you should know that ACM was M1A1 plus M2A2 over total M. So this into this, M into ACM would be nothing but M1A1 plus M2A2 and so on. And this would be equal to F external always. Alright, so that is how I reduce my calculations. I did not get friction into play at all. I did not bother about the friction. I simply wrote the net external force equals MACM. So net external force F equals capital M A2 plus small m A1 and solved it from there. Alright, so let's move forward. Next, let's talk about toppling. So what is toppling? So I did not prepare a slide for this because I wanted to show you what toppling is. So consider an object which is placed on a horizontal surface, alright, like this. Now you realize that every point here is pressing the ground equally almost. Alright, that is why from the ground it will feel a normal reaction also equally. The normal reaction is not acting at a single point, it is spread out actually. Alright, every contact point will be applying a force. Since every contact point is applying an upward force, you will actually have several forces of small magnitudes acting at these several points. But if these two surfaces are completely flat, then because of the symmetry, there is all these forces would be equal, and summation of all these small forces, okay, all these small forces, let's call this dn1, dn2. So you know the summation of all these small dn's will be equal to the total normal reaction, and because all these normal reactions are of the equal magnitude, the average position of the normal reaction would come out exactly in the middle. So you remember, you apply the normal reaction always in the middle for a block, and that is why you see that there is no torque. If you try taking torques about the CM, because all the normal reactions small dn's are evenly spaced out, they don't create a net torque. That is why if I wanted to replace all these small forces by a single n, I will apply that single n passing through the CM, so that when I see torques about CM, I should not get any. So that is my condition for rotatory equilibrium. For translator equilibrium, I am getting n equals mg. Right? This is for translator equilibrium. However, this body is also in rotatory equilibrium, because this is not rotating. So I can say that the net torque also must be zero. The only way the net torque can be zero is if n is passing through the CM only. So that is what happens, because all these small n's are evenly distributed. The average position of n comes out in the middle, and now you can represent the n as a single force passing through the CM, single vertical force passing through the CM. So what do I do? I am unable to solve SHM from Anurag Mishra, HC Verma done. Naman, what are you doing with HC SHM already? Oh, okay. You are a 2020 student. So okay, I'll tell you what. You find me on Telegram. This is my ID on Telegram. You find me on Telegram and let's discuss it over there. Alright, let me focus on the class here and you can find me on Telegram. Get in touch with me, I will help you out. Okay. So as I was saying, because of such a distribution, N, when you represent N as a single force, it is not a single force, it is not acting at a single point, it is acting at all these points. Okay. You don't have access to Telegram. Okay. Okay, then do one thing, Naman. I can help you one more way. Yeah, you can make an account. Second thing that what you can do is there's a description box below. Okay, in the description box you can fill a form. If you have any query, leave your number there, and there you are asked which educator you want to get in touch with. So leave my name there. So leave your number, leave my name, that say that you want to get in touch with Rohit Dixit, and the team, Unacademy team, will pass your number to me and I will get in touch with you. Don't worry. So I hope you guys followed this. I hope you guys followed that for a big block. Now I will simply write mg like this and n like this. I hope you realize mg is also not acting only at a single point. mg is not acting at a single point. mg is also acting at different points. For this mg would act like this, so dmg, dm1g, and so on. For this point, it will act like this, so dm2g. But we apply it on the cm. Why? Because not actually cm, but cg. And cm equals cg in case of uniform gravitational field. Uniform gravitational fields, I know the cm and cg collide. So I am actually applying the force of gravity at the center of gravity. The gravitational force also is getting applied at every point mass. Every point mass is feeling the force of gravity, but I represent it with a single force by the help of CG, the concept of CG. Center of gravity was the single point at which all the net weight of an object can be applied. So now we can replace the mg and the n by single forces passing through the cm, because G is uniform. Assuming G is uniform. Okay, I hope you guys followed me till here. How N is a single force, how N becomes a single force passing through the CM, or yeah, it actually CM only. It doesn't matter where CG is. Okay, please let me know you followed this. Then I want to show you something else. Did you follow this? Do you follow me so far? What I told you about N actually acts at different points, but we represent it by a single force because the average position of that single force becomes that way. Okay. Now imagine a second condition. Now imagine that I applied a force here. Now what will happen because of this? If I look at my CM, this force is giving an angular, is giving a torque about this. So this guy has a tendency to rotate like this, which means because it wants to rotate like this, these guys start pressing the ground with a greater force. You will realize these parts, the ones beyond this half, will start pressing the ground with greater force, and these parts will start pressing the ground with smaller force. Alright, the compression of ground would be higher for the parts which are, because these parts have a tendency of going down. So these will push the ground harder. And now what happens is that the average position of N becomes shifted. You can see this. Okay, let me show you an example. So if this guy is here, and if I apply a force, and I still see that under this force, fine, the force translator equilibrium is being maintained by probably friction, but how about the rotatory equilibrium? How about the rotatory equilibrium? How is the rotatory equilibrium maintained? Think about it. No, not at the corner, not necessarily. The average position would shift. The average position would shift depending on how much is required to counter this. Right now, I'm assuming that my normal reaction, which I showed earlier with a green color. So let's stick to that color. Now I am saying that normal reactions position, average position would shift. So the average position shifts. Average position of N shifts. Now if you draw the FBD, let's draw the FBD. So there is mg here. Let's use different colors for different forces. Okay. So let's use blue for mg. So I have my mg acting like this. I have N acting like this, and I still have friction. Why? Because this was an equilibrium. So if this was an equilibrium, the guy balancing the horizontal force must be friction. So these are the four forces that I'll have. I have capital F, which is getting balanced by friction in the opposite direction. I have mg, which is getting balanced by N. So for translatory equilibrium, what all can I say? For translatory equilibrium, I can say I can say F equals small f and N equals mg. So that takes care of my translatory equilibrium. Yes, the normal would shift. And why is it shifting? Because these guys end up pressing the ground harder. This part ends up pressing the ground harder. That is why the average position shifts. And now that N has shifted, it can produce a torque which can counter the torque of F. Okay. So here, this is still in equilibrium. So both translatory and rotatory equilibrium, right? Even if I am applying a force, what happens if I keep increasing the force? If I keep increasing the force, there will come a point where at some point this lifts. Okay, that is what toppling is. Okay, so let's see. Now if I notice, I remember that if the body is in rotatory equilibrium, then the torque about any point must be zero. All right. So let's take torques about point O. Let's use another color. Maybe this. Yes. So torques about point O. So if you take torques about point O, N is trying to provide a torque in this direction. The torque due to N would be in this direction, right? Because when seen from O, what is this guy doing? This guy is pushing it upwards. So pushing it upwards. So if this was here and if it could move upwards, so it would have rotated it in the counterclockwise direction. Similarly, where is the torque due to F? Torque due to F is in clockwise direction. Alright, so for translatory equilibrium, I can say that suppose this has shifted by a distance x. Suppose this is shifted by a distance x and this had a height h. This had a height h. So now for translatory equilibrium, what can I write? Or for rotatory equilibrium? For rotatory equilibrium, not only do I know that N is balancing the torque of F, I can also find X by the amount by which it shifted. Okay, how? For translatory equilibrium, taking torques about O. Let's take all the torques about O. The reason why I am taking torques about O is taking torques about O. The reason for taking torques about O is that the torque of friction and torque of mg becomes zero. So the only two guys that are producing torques about O are capital F and my N, and the torque due to N would be N times X, because X is the perpendicular distance of N. So I can say that this is producing counterclockwise torque, so that is positive, plus N times X minus F times H equals 0. Okay. So from here I can find the value of x also. Let's start substituting these values. I know n was mg. So I will find x equals f times h over mg. So this is the amount by which the n would have shifted. Okay. Now you will notice one thing. If f is 0, consider different cases. What happens if f is 0? Then x is 0. Right? That is the case if there was no force acting. If there was no force acting, then n passes through the cm. The position has not shifted away from the cm. But the moment I apply a small force here, the n shifts one bit. What happens if I increase f? If I increase f, you realize x will increase. So the moment as I go on increasing the value of f, the shifting of n would be further and further, and eventually there will come a point when the entire n would have shifted to the edge of the block. Alright, so I know if f increases, x increases. I can see that from the equation written above. Right, but there is a limitation to the shifting of n. It cannot go outside of the body. It's a contact force. The maximum that your n can shift is it can reach the edge. It can reach the edge, and you would basically, what is happening is that this entire part has slightly risen up. So that is why there is only one contact between the ground and the object, and that is why all the n is coming from this single point of contact. Okay. Now what happens? If I increase f even further, n cannot shift anymore. Here n was shifting to counter the torque of f. And if I increase the value of f more than this, the value that led my n to shift to the edge, so far the equilibrium can be maintained. Okay, so far the equilibrium can be maintained, but if I applied a force higher, the n cannot increase its torque. The n's magnitude is fixed, right? The only way n can increase its torque is by shifting more and more. N has a constant magnitude mg. Doesn't matter where it was acting, whether it was slightly shifted, then also it was mg. Whether it was not shifted at all, then also it was mg. So the only way n can increase its torque is by shifting more and more. So to maintain rotational equilibrium, what happens is that it starts shifting. If you increase f, it shifts some more, but it cannot shift beyond this. It cannot shift beyond the edge of the object. So this is the maximum torque that n can provide. Alright, so this is the maximum torque that n can provide. So a corresponding force would be the maximum force for which the body can maintain its rotatory equilibrium. If I increase my force beyond this value, then there is no way the rotatory equilibrium can be maintained, and you will see that this object will topple. So if I increase the force, see, it topples. So this is toppling, when it cannot maintain a rotatory equilibrium. Okay, I hope you guys understood what toppling is. If 4 is on cm, toppling will not occur. No, it will occur. It will occur. Why not? About O, it will still give a torque. No. If h is 0, then toppling will not occur. If h is 0, then toppling will not occur. Notice one thing. Okay, notice one thing. If I apply a force here, this just slides. This doesn't topple. If I apply a force here, it starts to topple. If I apply a force here, it topples easier. You can try this. The higher you apply the force, the easier it gets to topple this thing. Right? The lower you apply the force, the harder it is to topple. Why? Because the torque of F, you are reducing the torque of F by reducing the height. So if you applied your F here, then there will be no toppling. Don't worry. If F was here, that means H was 0. Then the end doesn't shift and it never topples. No matter how much force you apply. You pull it like this, it will never topple. I can apply any amount of force, it will not topple. Okay. I hope you got that. Though there is a slight problem, it will topple then also, by the way, unless it slides. If it doesn't slide, if it slides, then all right. But otherwise, there may be a condition where it will topple, because O will become non-inertial the moment this starts moving, and then you have a pseudo force that can provide a pseudo torque about O. So I will get into that later. But the point is, N will not shift if F is 0, initially at least. Alright. So, from here I can find that if the dimensions of this, let's write some dimensions for this. Alright, let's use some new color. So if this was B and if this was A, alright, then I know X is this, and I know X equals F H over mg, and X has to be less than equal to A by 2. Right, X cannot become greater than A by 2. That is the maximum shift that can happen in case of N. So I realize that F should be less than equal to mg A over 2h. So this is the range of force for no toppling. Alright, this is the range of force for no toppling. If the force is in this range, then it will not topple. Only if the force exceeds this value, then the toppling will happen. Okay. Now, most of your questions that are asked say that will a body topple first or slide first. So let's see. So this is the condition for toppling. So what is my condition for toppling? From here I can say condition for toppling. Condition for toppling is F should be greater than mg A over 2h. Alright. Similarly, what is the condition for sliding? Now look at this equation. Look at this equation for translatory equilibrium. Alright, for translatory equilibrium to maintain, which is for the object not to slide, F should be equal to F. I know also for translatory equilibrium, F equals small f. And what do you know about small f? Small f is static friction, and F is always less than equal to mu mg. Alright, why? Because in this case N is equal to mg. So condition for, what is condition for sliding? Condition for sliding becomes would be that F should be greater than equal to greater than mu mg. So now you've got two conditions. If this happens, then the object will slide. If this happens, then the object will topple. These two will be two different values. So whatever is smaller, that will happen first. If mu mg is smaller than this entire thing, okay. If mu mg is smaller than this entire thing, then the object will slide before toppling, and if this term is smaller than mu mg, then the object will topple before sliding. Okay, so please remember, that is all that your questions are going to ask. Most of the IIT questions ask whether the object will topple first or it will slide first. So check your conditions, whichever is smaller, that will happen first. Alright, so let's just write here. So if mg A by 2h is smaller than mu mg, then toppling happens before slipping. And if it's the other way around, then of course the result is the opposite. If mga over 2h is greater than mu mg, then toppling happens, then slipping happens before toppling. Alright, so remember these conditions. This is what your questions would usually ask you. Which one is happening before, which one is happening earlier? Is the toppling happening before slipping, or if the is the slipping happening before toppling? Okay, so you should know why the object topples. The object topples because as you provide a rotatory torque to balance that rotatory torque, the end starts to shift. As you increase your rotatory torque, the end shifts more and more, but the end has a limitation that it cannot move out of the body. So there is only a certain amount of shift that can happen with N. So that there is only a certain amount of torque that it can balance, an external rotatory torque that it can balance. If the external rotatory torque is higher than this torque, then the object will topple. Alright, it will not be able to maintain its rotatory equilibrium, it will start rotating, and that is what we call toppling. Alright, okay, I hope everybody followed that. Please let me know you followed everything that I told you. Please let me know that you guys followed everything that I told you so far. This is a tough concept. Let me know if you followed me so far. Guys, I'm feeling quite tired. Okay, fine. Thank you. Now, why don't we try a problem? Now, I will take a break. You guys try this problem. Let me have some water. Let me get some rest. So, you've been told that a uniform cylinder of height h and radius r. So, this is the cross section of a uniform cylinder. You will see the uniform cylinder as a rectangle, right? So, this is a uniform cylinder of height h. So, height is h and the radius is r. Alright. So, a uniform cylinder of height h and radius r is placed with its circular face on the rough inclined plane, and the inclination of the plane of the horizontal is gradually increased. If mu is the coefficient, then under what conditions will the cylinder A slide before toppling, B topple before sliding? Okay, so try this problem. And please write trying in the chat so that I know you guys are trying. See, on the horizontal ground, you have to apply an external force to cause toppling. But on an inclined plane, the mg component is only providing you the rotatory torque. So that is your hint. Instead of this F, which was providing the toppling torque here, who's providing the toppling torque here? This guy. Alright. You need a force which is parallel to the ground or parallel to the surface of contact to provide a rotatory torque. In this case, the one component of mg can provide that. So that is why an external force is not needed to cause toppling. If you increase the angle enough, if you go and increase the angle enough, then you will see that this topples. Okay. So all you need to do is increase the angle enough. If you increase the angle enough, mg sin theta value goes on increasing. So the toppling torque is going to increase. Okay, I hope you realize that. I hope you remember the slipping condition here. What is the condition for slipping? That theta should be, tan theta should be less than mu, less than equal to mu. That should be a result that you should remember by now. So condition for slipping, I already told you, you don't need to calculate, okay? You should remember this by now. If you don't remember this, then revise your concepts. So condition for slipping, remember that is how we used to find mu. This was the angle of repose. Is tan theta or theta is less than equal to tan inverse mu. If theta becomes greater than tan inverse mu, then slipping happens. As long as theta remains less than equal to tan inverse mu, then the slipping does not happen. I hope you remember that. By the way, everyone else, I would like you to learn from Moesha. I think I really appreciate the way Moesha handles the studies. Very regular for online lectures, always pays attention, always participates in the discussions, whatever doubts Moesha has, they are, uh, it is always asked, okay. So Moesha always resolves the doubts that they have and always tries the problem. And that is why I see most of the times Moesha is giving me the correct answers also. Okay. So I think that is in fact what I told you today in the video, how to make the most of your online lectures. I think Moesha is an ideal online student. So I think others should realize that and learn that from Moesha. See, that encourages a teacher like me also. If you know the student is participating and I can see that student is learning, what I'm trying to say is getting through to the student, then I also feel encouraged. If you don't interact, if you don't ask questions, if you don't let me know that you're understanding the concepts, then I also start feeling demotivated. Okay, I am trying so hard to explain you something, but you're not getting it. Okay, so yeah, if you're not participating well enough, then it becomes demotivating for the teacher also. So participate as much as you can, try hard as much as you can. Trust me, that motivates us also as teachers. Any teacher would tell you that. No problem, Maisha. And I'm sure you'll get a good result in your JEE exam because I think you have a good hold of your concepts. All right, but trust me, not everybody seems to feel that way, right? You're the only person that I see giving me constant inputs and giving constant replies. Not everybody else is as participative. So a good teacher also needs a good student to transfer the knowledge that I have. All right, so let's solve this. Okay, I hope others are trying as well. Tanmay, are you trying? I haven't heard from Vineet in a while. I don't know what he's doing. That is the only problem in online lectures. Students, they can come and go as they please. They don't want to stay focused for the entire lecture. If some discussion starts getting more intense, then they find it easier to just leave. Which is not the way. Which is not the way. If you want to learn, if you want to get a good rank, you have to take that pain. You have to put in that effort. Remember that. Otherwise, you probably don't want a good rank. Okay. But if you do, trust me, you will have to take that pain. Even if a discussion is getting very intense, try to focus, try to understand, try to listen to me. Cross question if you don't understand anything, that's fine. I mean, that is why I'm here. If you're not understanding anything, you can ask me again. I will explain it as many times as I can, at least. All right, Ankit is also back. So I will just discuss the solution of this, and that is it. That is the last topic that I had planned for rigid body motion. Okay. Okay, Ankit. Good to see that you are also very active. I would encourage everybody to be this active in the chat. Oh, you answered. I haven't seen any answer. Sorry, I did not see the answer. Could you post your answer again? I don't know. I can't see your answer. The last After trying, I don't see any answer from you. Okay. Anyhow, let's go over the solution. So condition of slipping, I already know. I already know this is the condition for slipping. This everybody who is planning to take the JEE in 2020 should remember this at least. So what is the condition for toppling? Let's see. So let's see, the torque of mg sine theta would be balanced by n would shift by some x. Alright, and if I take torques about O, there will be friction in this direction, there would be mg in this direction, mg cos theta. So I can simply say that for translator equilibrium, if you could post your answer one more time, maybe that would be better. So I can say for translator equilibrium, mg sine theta must be equal to f, and so that is my equation number 1, and n must be equal to mg cos theta. If these two equations happen, then translation is taken care of. How about the rotatory equilibrium? Let's take torques about O. So now I can say for rotatory equilibrium, taking torques about O, what am I getting? I am getting one torque of mg, which is counterclockwise, and one torque of n, which is clockwise. So these two torques should be equal. So I know this is h by 2 because h was the height of my cylinder. I know the cm would lie in the middle. So mg sine theta into h over 2 should be equal to n times x. Right. So from here, what I'll get my x as? I'll get my x as this divided by n, and n is mg cos theta. So I would get tan theta into h over 2. And what do I know about x? Okay, I can't see it again. I still can't see it. And this should be less than equal to r. Alright. So condition for toppling, what does that become? So condition for toppling. Condition for toppling is that tan theta should be less than equal to, for no toppling, is tan theta should be less than equal to 2r over h. Similarly, condition for no slipping is tan theta less than equals mu. Okay, you can see that from here. This equation also. This mg sine theta should be less than equal to mu mg cos theta, so you will get tan theta should be less than mu. So now you know the conditions. Okay, now you know the conditions. So if 2r over h is greater than mu, slipping happens first. And if this is less than mu, then toppling happens first. If of course both are same, then The toppling and the slipping would happen simultaneously. Alright, I hope this was the answer that you had, Moisha. Sir, whenever I use symbols like less than or slash or brackets, my answer don't reach you. Okay, maybe so you don't use that. Don't use that, right? Theta max. Okay. So, but I hope this was the answer that you were getting. This is the condition. Okay. So was this the answer that you were getting? Just confirm it. If this wasn't, then go through the calculations, see where you went wrong. Okay. So this is a very interesting problem. Again, this is supposed to be a tough problem, by the way. But yeah. All right. So no issues there. Alright, so that is it. That is all that is to know about toppling. So I guess since you could solve this, you guys should be comfortable with toppling also. So that concludes the rigid body motion. I have covered every topic. Now I had initially planned to discuss some previous year questions, but now that we have already run out of time, I would ask you to solve these problems. These problems would be very easy. Okay, if you can solve all this, then yes, the problems should be easy for you. So why don't you do one thing now? Try these JEE problems at home. Okay, so you can download some previous year JEE problems, or if you have a question bank of previous year JEE questions, then go through the questions of rotation, and trust me, you should be able to solve every question, whether it is of mains or it is of advanced. Okay. The content that I have covered covers the entire syllabus of advanced level also, so you shouldn't have any problem. Alright, so these are a few questions that I had taken up initially, thinking that I'll discuss these, but since we are out of time, maybe you can take screenshots of these. Since I had already put in the efforts of noting these, making a list of these 3-4 problems, so take a screenshots of these. Take screenshots of these, and maybe you can try them later at home, and trust me, you will find the correct answers. Yes, rotation ends here. From tomorrow, we can start gravitation. So gravitation is also a very interesting topic. I am quite fond of gravitation. But it's a small topic also. So it'll probably be over within 2 or 3 lectures only. And after gravitation, we'll move to fluids. So in case you guys wanted to know what sequence I'm following. So mechanics is done. Now we'll move to gravitation, and then we'll move to fluids, fluid dynamics. Okay. So take a screenshot of this. Now take a screenshot of this. This was in AIEEE 2005. Okay. Take a screenshot of this. This was in JEE 2007. JEE, when I say JEE 2007, that means advanced only. Till 2011, there was AIEEE and IIT JEE. After that, IIT JEE became advanced and AIEEE became mains. Okay, so I hope you have taken a screenshot of this. Finally, this is a very, very interesting problem. So definitely give this problem a try. Okay, this is a tricky one. Okay, this is a wonderful problem from rotation. JEE 2011, it was asked, so that means JEE Advanced. Okay, so take a screenshot of this and you can try this later. Yeah. And this was JEE Advanced 2015. This should be easier. This is quite similar to the problem that we discussed. Alright, where you have to find the range of two objects. If you remember that, this is very similar to that. Okay, so take a screenshot of this. Yep, there you have the entire question. Alright, and there is nothing behind my head much. Okay, so even if I move, you will see that this is the diagram. I don't know. You'll have to see. I don't remember exactly. I did not read it right now. Alright, so these are the questions that I wanted to discuss. That is it from my side. Rotation ends. We'll start with gravitation from tomorrow. So practice your problems, your previous year problems, and I think if you haven't finished your HC Verma by now, please practice problems from your HC Verma also. You shouldn't have any problem solving any kind of a question. Okay. So before I leave you, you can download the Unacademy app, get the subscriptions, and join regular courses that I will be taking on the app. Okay. So I'm taking this series for 2020 students, but I will be floating regular courses also of my own on the Unacademy app. So if you want to join me there, then you can get subscription following these simple steps. Now, when you are getting your subscriptions, don't forget to use my code. My code is RDLive. So remember this code while getting your subscriptions. All right. Now, if you liked today's video, if you thought you got to know new things and you learned something different, then press the like button and share it with your friends. All right. Also, press the bell icon so that you keep getting notifications of all the lectures and sessions that are happening on JEE English channel. The PDF of all the slides used would be available for download very soon. I haven't had the time of uploading these slides from my end for the last 2 days. That's why there may be a slight delay right now. But I will try and do that tonight only. So by tomorrow, you should have all the PDFs uploaded. Okay, so you can join us on the Telegram app using this link. Okay, and so that you don't miss any notifications. Because a lot of people told me that they are not getting the notifications even when they've subscribed to the JEE English channel. So join us on the Telegram app also. You can find me on the Telegram app using my user ID, which is this. Okay, and one more time, if you like studying from me, if you think I can make you understand your concepts, your physics, then get your Unacademy subscriptions using my referral code, which is RDLive. You will get 10% off also using this code. Okay, so remember to do that. So I'll see you guys tomorrow, and till then you can take care and keep practicing your problems. Bye-bye. Thank you guys.